I'm Neela Klein, and you're going to hear from my collaborator and friend, Elizabeth Ray, in just a second. Just a brief overview before we get started. This is obviously 100% through Zoom, so Liz and I have spoken about if one of us ends up having internet troubles and freezes or something like that, the other one's probably going to jump in and take over wherever they're at until internet stuff gets sorted. So if we end up interrupting each other from that perspective, just know we had that somewhat planned. We're going to be going over best practices in getting started with SPSS. This is assuming that folks have really minimal exposure to SPSS. Maybe they've opened it, used it for one analysis, but want to know the program a little bit more thoroughly. But we're going to be pulling from some stuff such as getting data from Qualtrics, and it's going to assume some statistical knowledge. So the point of this is how to interact with SPSS rather than a whole overview in some of the deep statistics. At any point throughout this, please feel free to send a question in the Q&A or send a question in the chat. Us or Emily will be trying to monitor that throughout so that we can answer questions as we go. But is there anything I'm forgetting before we get started, Liz?
No, I think that gets us started. The only other note that I would add is if any of you feel like you're rapidly taking notes throughout this, we will be posting this as an open source resource afterward. So we've built these slides so that you can come back to them as a resource. So some of them may be wordy. Feel free to not feel like you have to write all that down, just knowing that you'll have access to that resource in the next coming few weeks.
Yes, this is currently being recorded. The current plan right now is for it to be available to everyone in the webinar and also more available widely, assuming all goes smoothly. And regardless, our slides will be available, like Liz said. But again, feel free to ask questions as we go. Most of these things are not things that either Liz or I has memorized. We ourselves have these slides next to us as we're working with SPSS. So let's get started. Just a brief overview of what we're going to be doing today. We're going to be talking about the different views in SPSS, so how to use SPSS in its different windows, and we're going to have some analogies comparing it to Word and Excel. We're going to be talking through the basics of SPSS syntax, so the code in SPSS, and then we're going to go through some analyses, specifically reliability, correlational analyses, and then simple and multiple regression. Throughout this, and at the end, we're going to have some pro tips about how to use syntax, and then also why you should use syntax. And then if we have time and if folks are wanting to, we have an activity with a data set that you can play around with and have some answers to mess around with to see if you understood what we went through throughout the presentation. So let's start with opening data. So throughout this presentation, we have SPSS on slides. So we have our slides, and then we also have screenshots of SPSS, because one of the main things you will find with SPSS is it doesn't like to run in tandem with Zoom. It often takes a lot of processing power of your computer. So we have a lot of screenshots of SPSS throughout this slide so you can see it on the actual interface. So in SPSS, you can have no data and you can go in and write it by hand. Let's say you had paper surveys and you want to go and write in what every participant said, you can write it in just the same way you would interface with Excel. What's more common is that you might import it from other documents. So you might import it from an Excel sheet that already exists or from a CSV. And the way you would do that is go into SPSS, you would click File, you'd scroll down to Import Data, hover over that, and then you can import it from Excel, a CSV, or any of these other file types. I will say from this, it can get a little bit dicey depending on how you're importing it. If you import it from Excel and the Excel document is not already formatted super nicely, it might not come super nicely into SPSS. The way that I work with SPSS 90% of the time is I get my data from survey websites such as Qualtrics. So if you were working with the website Qualtrics and I collected data on the website Qualtrics, I would go into Qualtrics, I'd move from survey all the way over to data analytics. And then I would click this export button, this export import button, and then click export, which would open up a menu somewhat like this. The automatic way that it would download data is as a CSV, but I'm going to click here the SPSS option, and then you don't see it right here, but there's usually a see more options right around here. And I always click that because if you have anything in here that's randomized, so let's say some participants answer one question, some answer another, or they get split based on how they answer a question before, you randomize the order of certain things, so on and so forth. If you want that to appear in the data set, so if you want to know what conditions folks saw, you have to click this button that says export viewing order from randomized surveys. And I just point that out because that might be a big hiccup when folks are using SPSS and downloading it from Qualtrics. So from there, you would click OK, you would download it, and you would open it like any other file on your computer. Ah, yes, those are the buttons you would be clicking from there. So we can pause here, see if there's any questions, if there's any questions in the chat, just on how you would download your data. But from here, we're going to move on to how do you work with the data in SPSS once you have it. So I'll pause for just a second. Okay. And folks can feel free to interrupt me if I missed anything. So SPSS has two different types of views, as I mentioned earlier. I like to think of these as two different sheets in Excel, and they're even formatted on the page kind of like Excel is with its sheets. So the first view is the data view, and this is when you would look at individual data points. So what did Tommy put as his age and his height, and what was Tommy's well-being? And then you can also see that for Larry and Leslie and so on and so forth. This data view is also nice for scanning for missing data. You can edit the individual data in here like you can in Excel, or you can sort your data by specific variables. Let's say you want to see your participants in order by age. You can go up to the age variable and sort from there. In this variable view, or excuse me, in this data view, each line is a participant, so each row is a participant, and each column is a variable. So let's see what this looks like in SPSS. So this is our data view. As you can see down here, I hope y'all can see my mouse. Liz, are you able to see my mouse?
Not right now, actually. We were able to see it on the last slide. I'm not seeing it at this second.
Okay, well, we can go back. What about now?
Yes, now we can see your mouse.
Beautiful. All right, so this data view down here is how you toggle between the two. As we said, it looks kind of like sheets in Excel. And in this case, each row, so row one is going to be a single participant, and each column is going to be a variable of data collected about all of those participants. So row one is, let's say, participant who is denoted by the ID 2005. This is their birthday. This is their gender denoted by zeros and ones, their age, so on and so forth. And if I wanted to rescale this to look at participants in ascending age, I could just click with two fingers on age and it would have options of sort ascending or sort descending. But there's not only data view in SPSS, there's also variable view, which was that other window that we saw. Variable view collapses across participants and looks only at the variables that you are collecting data on. So this tells you information about the variables, such as what are the individual items in a scale, how are scale totals done, and also what types of data are in each of those variables. And we're going to go through that in a little bit more detail. This is really good for making sure that the information about your variable is correct before you run the analyses. So are they named something that's useful to you? Is the type of data, so string versus numeric versus a date, so on and so forth, are the decimals going out the same way you want them to? Those are all things to check before you start running your analyses, and you would check them in variable view. So how do you see this in SPSS? Ooh, it's loading. Oh, goodness. Okay. There we go. First technical issue, everyone. Let's hop back on that. Okay, there we go. Variable view. Apparently it's a little bit finicky today. So variable view down here, right next to data view. Here, each row is going to be a single variable. So we don't see Tommy's data or Lawrence's data. Here we see the data that was collected about those folks. So their ID is going to be a numeric type, but gender was collected as a string, which maybe we don't want it to be here. And this gives you information about the individual variables, such as the variable gender. We're going to get into what the rest of these columns are in a little bit later. All right, and we're going to start here. So let's start with the type. A type is the second column from the name, so name denotes the variable name, and the type is shorthand for the type of data that is being collected. So let's say that you don't want IP address to be a string, you instead want to be numeric, or you wanted gender to be denoted as numeric instead of a string. You don't want to write out cisgender woman, so on and so forth. You want it to be denoted by numbers. The way you would do that is you click those little three dots next to the variable and next to the variable type. And from there, a window like this will open up, and then you can just toggle between these options here. So if this was numeric and I instead wanted to be a string, I would just click this button and then I could press OK. Throughout SPSS, there's going to be a bunch of buttons that it will not let you move on until you press OK. So that blue OK button is going to be your best friend. Always make sure you're clicking that, or else it's not going to let you run anything else. So that's how you change the variable type. Another thing in SPSS that I think is probably the most useful and is not as common in a lot of other coding languages or in a lot of other coding softwares is the label function. Now, if you're downloading your data from Qualtrics, these labels will be the exact question that participants saw. So for example, we asked them to provide their prolific ID, prolific being a place that we collected data from, and this is the exact phrasing that they saw to get that question, and Qualtrics added it automatically. If you collected this data in a matrix type question in Qualtrics, it is going to ask both the full question that was given as well as each individual scale options. So for example, we asked race as a matrix. So our overall question was, what is your race? Do you identify as East Asian, South Asian, Black, or African American, and so on and so forth? And those were individual options that someone could click on or off. And so each of those come out as well as that main question. If you need to change the labels in here, you just double click in here and highlight it, and you can write in it like you would in any Excel cell and spreadsheet. I really like in here that I often leave notes for myself. You can make these as long as you need to, and also just like in Excel, these columns are expandable outwards. So sometimes you can see down here, we didn't get the full question. You can expand it out to see more of it. But I often leave notes for myself for how I calculated variables and what they're specifying to me if the name is not super telling. All right, so going on from the labels, some of the other pieces that are important here are the values over here. So values are how you would label specific numbers for a categorical variable. So let's say that I measured year in school and folks said if they were freshman, sophomore, junior, senior, graduate students, so on and so forth. But when my data came through, I have 1, 2, 3, 4, and I don't want my output to be labeled in that format. I want to tell me who was a junior, what if there was a sophomore, what the frequencies were, so on and so forth. So I would then assign values or labels to the values of those numbers. And the way that I would do that is I'd click those three little dots down here like before, and a window like this will pop up. This will all be blank, but I would click on this plus sign and I would put in the number under the values column that I'm seeing, and I would add in a label for myself that is telling about that number. So it might be that you denoted gender as 1 equals cisgender female, so on and so forth, and then you just keep adding more and more of these columns until you have all the values that are relevant to your data here. From there, you'd click OK, and you would see that the values have been added because you would have something that looks kind of like in the IP address down here, rather than it saying none. And this means that your output for these values will be labeled with, in this case, what level of education folks have instead of 1 and 2. And that's the reason why you do that. This is an entirely optional step, but it does make your output a whole lot more readable. And then some columns that I don't use super often, but it's good just to know what they do. The width column here denotes how many characters out the values inside those columns can have. So for example, the start date can go out 20 characters. So if I want to add more detail into the start date, like the exact time that someone started, and it ends up taking up more than 20 characters, I need to go into the width here and make it a larger number. This also comes into play for things like significant figures, if you need more decimal places, but you can also use the decimal columns over here, so how many decimal places out things will need to be. but the width mostly comes into play if you have a string type variable and it might be super long. So if you had participants who had a short answer type question and someone wrote a whole lot of information and they're capped at 200 characters, they might have the end of it cut off. Most of the time when you download the data from something like Qualtrics, the width will automatically calibrate to whatever the biggest one is. But if you're adding something in and you see it stopping, letting you type more, it might be because the width is being constrained. You need to change it in here. Like I mentioned earlier, decimals is just how many decimal places out do you want any given numeric value to be? Think back to chemistry and significant figures. This again usually calibrates to if you already have variables that go into decimal places. But let's say you're calculating an average and you want 3 decimal places out, you might have to go and add that in here if you added it after the fact. Lastly, there's this missing column. So this is what value would you like your missing data to be assigned? It is automatically given just this little period. So let's say Timmy didn't tell us what age he is. There would just be a little period next to Timmy under the age column, and there would be no value here and it would be skipped over for analyses. But often we want to exclude folks that have X number of missing values for their study. Maybe I want to exclude folks that it's missing if they said if they paid attention in the study, so on and so forth. And sometimes it's helpful to assign a specific value to those missing data. Often something like 9,999 or -99 are good defaults because you might use a filter variable to remove all participants that have negative values for X variable, or you might remove all values from the data set that are above 10,000 or something along those lines. So this is why some people use strange numbers like -99, but that might come into play if you have an analysis that is particularly sensitive to missing data. So that is most of what we have for our variable view and our data view, and just what are all these comments meaning in SPSS. I'm going to pass it off to Liz to talk about some of the initial analyses. This would also be a great time to drop any questions you have in the chat for what are any of these buttons in SPSS.
Great. Thanks for getting us started, Neela. So I'm going to start by chatting about just some initial analyses here. So to get us started, we'll start with descriptive statistics. Descriptive statistics are going to have a variety of uses in whatever project you do. So for example, you can use descriptive statistics to give you an overview of variables. You could use it for reporting your demographics. And it can also be used to give you a variety of different measures. So this could be central tendency, so things like mean, median, and mode, or spread, so things like variance and standard deviation. To do this, we're going to be going through the point and click directions. Throughout this workshop, Neela and I are going to be referencing point and click directions as well as syntax. So I'll give a brief little overview on that before we go into more detail later. So here at the bottom of this slide, you can see point and click directions. Point and click directions just mean that you're like clicking on tabs, clicking on buttons within the programs. When you hear us use the word syntax, that means that we're using code and we're running code within the program. So we'll start off by just going over point and click directions. So you see that here at the bottom. You would click Analyze at the top tab, then click Descriptive Statistics, and then Frequencies. Or if you wanted to go for descriptives instead of choosing frequencies, you can choose from the drop-down menu, Descriptives. So let's go ahead and see what that looks like within SPSS. Okay, so here you can see that we have variable view pulled up right here. This is just for this example. You can actually do these options from any of these tabs here. So either from data view or from variable view. But for this example, you could choose here, click Analyze, click Descriptive Statistics, and then here you can see that you can choose either frequencies or descriptives. For this example, we're going to go ahead and choose frequency, and I'll show you what happens once you click this button. So once you've completed those point and click steps, it's going to pull up this frequency screen for you. From this frequency screen, you can move over variables from this left-hand box into this right-hand box to tell SPSS that those are the variables that you're wanting to run frequencies on. So for example, you can see that we've already moved over one race. But if we wanted to move over religion, we could highlight it, click this arrow, and then it would be in this box. Another option you have is to just drag and drop things into here. You also don't have to do this one at a time. So you can control or command multiple of these and either click this button or drag and drop them over. So just a tip, and if you're doing frequencies on a variety of different variables, you can move them over more than one at a time. So once you've moved over your variables, there are a variety of other options that you can choose within this frequency screen. So say, for example, you click the statistics tab here. What will pop up is this window that you see here on the right. From here, we can choose things like central tendencies that we're interested in. This is where we could choose things like mean, median, mode. But you can see that there's also other options here. So some of the common ones that I know that I use is standard deviation, variance, and min and max, just to be able to get an understanding of what your data is doing. So again, you want to make sure that you click continue here. Like Neela said, you won't be able to move forward without telling each box that pop opens either cancel or continue. So in this case, we would click continue, and then we would click OK. I also have brought up the syntax. We'll get into more detail about how you can use that later, but for now, let's just say that we clicked this OK button. One more detail here. When you're in this, looking at these boxes, moving variables from this left-hand box to the right-hand box, you also can order the variables in a way that's more helpful for you. So you may just like to use it the way that auto pops up for you within SPSS, but you can also choose to change it to variable names. So here, what it's actually showing us is the variable names, not the labels, but you can choose for it to show you the labels here instead. Right now, it's also sorted by file order. So for example, you would likely see just the intro timing, your beginning variables, and your final variables towards the end, but you can also sort them alphabetically if that's more helpful for what you're doing. So let's say you click OK here, and here's what would pop up. So this is a new window that will pop up for you in SPSS, and this is going to be an output window. Within this output window, we can start by looking here. There's two separate sections of this screen here. So on the left, you have this outline of the output here. So here you can see that this is the frequency that we just ran. Within this is both movable and it's also an editable outline. So you could change the word frequency here. You could say frequency of race and religion to give you a note to yourself to know what's coming back. But let's say you ran all your frequencies, you ran some more complex analyses, and then you realized, oh, I actually forgot to include age up in my statistics near the frequencies. If you're sending this output file to a collaborator or just saving it for yourself, you can drag and drop that new frequency that you run and bring it back up towards the top. So this is a feature that's similar to like an outline in Google Docs, if you're familiar with that, but it's also similar to like an audiobook outline, if that's more something that you're familiar with. So now let's go ahead and take a look at what's popping up on the right-hand side of this output window. What we see here is a few different things. We see just a statistics table here where we're getting information like how many participants were included in this. Of those included participants, what percent of those actually answered these questions versus how many are missing. You can also see information down here on what labels or what options were actually represented within that variable. And you can see the frequency and a variety of different percentages. I'll go ahead and tell you briefly what these different percentages are. So to do this, I'm going to orient you to this missing row so that you can see that as I'm talking through this. So beginning with this percent column, you can see that it's just labeled percent. So this one includes missing values. So to equal this 100%, so the total percent, it is accounting for these missing values. And it's actually attributing a percent to those missing, like the people within that missing group. This valid percent is what you would likely be reporting in your journal article reporting or within a presentation after you've already discussed data cleaning. So once data is already cleaned, you're going to want and already stated within what you're presenting, that is when you'll begin wanting to refer to this valid percent, which is calculating percentages only within those participants who gave us answers on this question. Okay. So next we're going to chat a little bit about creating variables, but continue to feel free to put questions into the chat as they just come up. All right, so let's chat a bit about creating a composite variable. So composite variables have a variety of uses within SPSS. You'll use creating a composite variable to make an average. This could be something like creating an average quiz score across the semester. You may want to create a total. So if you wanted to create a total of like a variety of number of items that were sold across stores, this is when you would be using a composite variable function. Furthermore, you can also create more complicated metrics using this composite variable function. So for example, if you needed to look at BMI in one of your studies and you simply had a column for weight and a column for height, you can create a composite variable to then create a new column that gives you that new calculated metric. So let's go ahead and see what that looks like within SPSS. To get here, point and click, you would click transform and then compute variable. Once you click compute variable, this is the screen that's going to pop up for you. So let's keep moving with that BMI example for now. So let's say that here in the target variable, I was wanting to create BMI. I would click into this box and I would enter the variable name of BMI. Then I would start focusing here on the numeric expression. So actually telling SPSS, what do I want to pop up in this column for me? So in this BMI example, I would move over weight, and then I would choose the numeric expression button here for multiplication, move that over. And then next, I would drag and drop the other variable for creating BMI here. From here, I would be able to click OK or paste, depending on the option that you choose, and this would create the composite variable for you. I'll go ahead and give another example of this. So in this example, you can see what it would look like if we were wanting to create a computed variable for the mean quiz score. So let's say that we had 3 quizzes throughout a semester and we wanted to see what the mean score is. We want to have a new column that's giving us this information. So we would enter that new title into this target variable box here. We would choose the function group to choose mean. So for the specific example, you would go arithmetic, find mean, and it would pop up here. When you choose mean in this box, you'll see mean with 2 parentheses that are blank. What you'll do from that point is drag and drop the variables that you want to be included in that calculation into those parentheses. So once you've done all those steps, your screen will look something like this, and from here you can click OK. Once you click OK, it would just create the variable. But from here is where I want to start introducing the idea of syntax to you guys. So what I said earlier was that syntax is like using code within SPSS. So how we get code in SPSS, you can either have it on your own, or you can have SPSS create it for you. So if you're unfamiliar with writing code, SPSS is a great beginner-friendly option. So let's go ahead and walk through the steps of getting code from SPSS, running that code, and seeing what it looks like to run that code.
Hey Liz, can I just add in something real quick?
Yeah, of course.
Folks, on this page, something that has tripped me up and I've seen trip up a lot of other folks is the target variable name. So all the way over on the left side of the screen towards the top, you'll see that we have underscores next to quiz and mean and score. This is because SPSS does not like having spaces in its variable names, and it gets very, very grumpy at you and will just say, no, you can't run it, but not really explain why. So I wanted to throw in there that we like to use underscores. You can also use dashes if you want to separate out by word, but this is a common place where SPSS just says no generally and doesn't explain why, and it's very often that you have a space in there that you don't realize or shouldn't be in there.
That's a really good point. Thank you for adding that in. So yeah, let's say that we click paste here, and then let's see what pops up when we click paste. So what will happen here is it'll pop up a new window again. So earlier I brought up the concept of the output window. Here we can see, let's see, I might be frozen on this end. There we go. Okay, so when you click paste, it'll click and pop open what's called a syntax window. So in this syntax window, we have a similar visual looking SIP output as we had of the output window. What we see here is an outline of the syntax that we've written. So this will give you a shorthand version of what we're looking at here. And then here's where it actually pops out the syntax or the code for you. And you can see here, compute, quiz score mean, that's the variable name that you gave it, Here's the numeric function that you wrote in that box. And what it's did is it's taken that point and click information and turned it into code for you. So looking at this syntax window, again, you can see the shorthand outline here within that shorthand outline. Again, you can relabel these things to make it useful for you. You can, again, move things around to make it the most useful for you or the collaborators that you're sharing it with. Another thing that I find really helpful in SPSS is annotating my syntax files. So annotations are simply what you see here in the gray text. So the black, blue, and red text is actually code or actually syntax. But this grayed out portion are called annotations. These are denoted by these asterisks here. So you can see that like if you do a whole line of asterisks that you can make like sections within your syntax file, but you can also just use a single asterisk to leave a note for yourself. So for example, we left a note for ourselves about what the following code is actually going to be doing. So now we'll begin chatting about how to actually go through doing some analysis within this program. So we're going to be chatting through reliability, correlations, simple and multiple regressions, but we'll be chatting through some other options about how to get information on other processes in this program as well.
Would you mind stop a little bit because I noticed there are guests in the Zoom wanting to ask for a little bit of clarification. So one of the guests was asking that they want to see how you enter the creating composite variable and also wanted to see or wanted to you to provide a recap about the code.
So I heard the first part of the question. Could you repeat the second part of the question for me?
So the second question from the same person is, I'm not understanding what you said about code. Please just a recap.
Okay, let me get to the correct screen here. Okay, so going from the point and click directions to the syntax window, when you click paste here, paste is another way of saying to SPSS, I want you to paste the syntax for me. I want you to create the syntax for me. So I'm not going to write the code. You're asking SPSS to write the code. When you click paste here, what will pop up is that new syntax window. Within that new syntax window, it will put it here for you, but it actually hasn't ran the code yet. It has pasted the code, but it has not actually conducted that process yet. So from here, you could highlight over like rows 3 and 4 here. So highlight over the code that it pasted for you, and then click this play button here. Once you click that play button, that's what's actually going to run the code for you there. Does that answer your question? Feel free to ask any follow-up questions. We'll go ahead and keep moving along right now. But Neela, did you have anything that you wanted to add to this?
No, that is most of it. So this is a really nice option for keeping track of what you're doing because it's also kind of a log of the work that you've done. So like Liz was saying, if you go through the point and click method and then press paste, you tell it what you want to do, and then you say, show me the code that you're going to run. So it's asking SPSS to write out for you on a screen the code that it would be running on the back end, so that you have a log of it and you can see what's specifically happening. And from there, you can add to it. So you can type in there and add more information. You can change the code, or you can just, like Liz said, highlight over it and run it. On the previous slide, the way that we wrote through how to get mean and then quiz scores was we just clicked into the functions algebraic, and then from there a button that says mean would appear, and then you just drag and drop over the variables quiz score 1, quiz score 2, and that's how this is created. We just added commas in between all of them so that SPSS knows that that's not one long variable in the inside the parentheses.
Thank you. All right, yeah, definitely let us know if there are any follow-up questions to that. And let's go ahead and skip forward and chat a little bit about reliability now. Okay, so beginning with reliability. Reliability is any measure of internal consistency where we're wanting to look at the internal consistency of a scale by correlating the items within it. So reliability is assessing how well items of a scale hang together. By analyzing reliability, we can identify incorrectly coded items. So for example, if you needed to reverse code an item and you haven't did that yet, by seeing reliability, this would likely give you a low reliability, which would hint to you that something is off there. Otherwise, maybe you reverse scored the incorrect item. This would also give you an example of how you can find that within your data. So there's a variety of different ways that you can measure reliability within SPSS and other programs, but even within SPSS, Cronbach's alpha is the most common internal reliability. So Cronbach's alpha is an estimate of the average correlation among all items on a scale. So this is also going to be the average of all possible split half reliabilities, but if this is something you're more curious about, feel free to ask Neela and I about it afterward. So to do the point and click directions within SPSS to get reliability of Cronbach's alpha, we would click Analyze, then click Scale, and click Reliability Analysis. So let's go ahead and see what it would look like if we did those point and click steps. So what's going to happen is that this reliability analysis box will pop up. Let's say that we were creating a variable for like emotion, and we wanted to see if that was reliable. Let's say that we created an emotion variable already, and we know that that emotion variable includes question 1 through question 9. So if we wanted to see if that was reliable, we would move those items from this left-hand box into that right-hand box. We could either include all of the scale items or just specific subscale items. And from here, it will be able to output for us either the code or the syntax to run this reliability analysis, or if we just want to stick to the point and click directions, we can click OK here, and that would be all of the steps needed to do a reliability analysis. One thing to note here is that if you've already created that composite item, you'll also have a composite variable name here that in this example would say emotion. You want to be sure to not include that composite variable in your reliability analysis because that's not what is meant to be included there. You'll want to only include the items, not the item that is representing all of those items. So once you run that pasted code or you click OK, this is what's going to pop up for you in the output window. So if we look up at this first box here, you can see this is how many participants answered all of those questions. So this is how many participants did not have excluded data here. Looking down here in our reliability statistics box, we can see the Cronbach's alpha that was given through us through this reliability analysis. And last here, you can also see this box that's telling us information about what happens with the Cronbach's alpha if just one of these items is deleted. So let's talk through this example just of this first line. So what is the Cronbach's alpha if agree 01 is deleted? So when agree 01 is included along with all the other items, the Cronbach's alpha is 0.894. But if we were to exclude this agree 01, then the Cronbach's alpha actually decreases to 0.858. And here's the cutoffs that you would use to be able to evaluate what that Cronbach's alpha means. All right, now let's chat through what it looks like to run correlations within SPSS. So we're going to be chatting about mainly bivariate correlations. There are other kinds of correlations that you can do in SPSS. So again, this would be an opportunity for you guys to ask follow-up questions to Neela and I. Today, we're going to be focusing on using correlations in SPSS to identify a linear relationship between two continuous variables. So to do this with point and click in SPSS, we would click Analyze, then Correlate, then Bivariate. Let's go ahead and see that in action. So here, if we were in SPSS, here you can see we're in variable view, but like I noted earlier, you could also do this from data view. You'll click Analyze, click Correlate, and Bivariate. And from here, this is the box that will pop up. Again, same process as anytime that we're doing this point and click direction. We'll go ahead and choose the variables that we want from here and move them over. In this case, we have two variables that we've moved over from that left-hand box to the right-hand box, so we're going to be looking at the correlation between these two measures. As with many of these boxes that we've shown you that pop up, it does have some options over here, so there are some things that you can click through to see if you have any additional information you want SPSS to give you. From here, you could click paste. It will give you syntax. You could run that syntax, and then the following would come up, but let's say that we just clicked OK here. This is what would pop up for you in the output window. So it will create a new tab here telling you that you have a new little section within your output. And here you can see the information here. So it gives you the Pearson correlation value, the significant level, and it tells you how many participants were included within this analysis. So are there any questions so far on either correlations or reliability? All right, wonderful. Well, I will go ahead and pass it over to Neela to start chatting to us about some regressions.
Awesome. Thanks, Liz. Let me rearrange my screen a little bit to move all of your lovely faces. So we're going to move into simple linear regressions as well as multiple regressions. I'm going to talk through what types of questions this might be relevant for your analyses. It's worth noting Liz just covered correlations. Correlations and a simple regression are mathematically the same, but they're interpreted slightly differently. So let's talk about how you would be using them. Oh, I do see a question in the chat. Someone just asked if you can run a multi-level model analysis with SPSS. I don't believe so. Most folks use R to run multi-level model analysis. There's some repeated measures type things that you can do in SPSS, but people don't tend to use it for multi-level modeling, no. But one of the simpler versions of multi-level modeling, one of the base pieces of multi-level modeling is the simple regressions piece. So there we go. Okay, so what is a regression and what types of questions can regressions answer? A linear regression is an equation of a model that tells you how well values in the IVs, denoted also known as independent variables, predict values in the DVs or dependent variables. Simple linear regressions only have a single IV and it's always a continuous variable, and they have a continuous DV dependent variable. Multiple regressions, and the only thing separating simple linear regressions and multiple linear regressions is that multiple linear regressions have multiple independent predictors, and we'll talk through what some of those questions are. And so the way that you decide if you need to use a correlation versus a simple linear regression is going to really come down to what types of questions that you're asking and also how the data is collected. So if it's looking at X causing Y, you're going to have a linear regression, but it's do X and Y tend to move together and have similar variability? That's going to be more correlation. So let's move into a specific example. So the regression equation will give you specific information about a regression line. I want you to think back to your first algebra class where you have those graphs and have rise of a run. It's going to be very, very similar to that. So what are the equations of a line? We're going to have a slope and an intercept for our regression equation, and I'm going to have the equation of a line and how to read this equation in SPSS output off to the side if it's helpful. But it's worth noting that in most manuscripts that you're going to be doing a simple regression or a multiple regression, you will not need to write out this equation. This is just in case it helps folks understand, okay, what's the intercept? What's the slope mean here? So let's imagine that we want to predict the number of hours a graduate student like myself or Liz spends writing our theses from the number of hours that we slept before. Maybe we think that the number of hours that we slept before is going to cause the number of hours we're going to spend writing our theses. So in this way, we're going to regress the hours that we spend writing onto the number of hours that we slept the night before. The hours we spend writing being our dependent variable that we're getting information from our independent variable, the number of hours we slept the night before. I have a little asterisk here to say this is not real data. Please do not go back to your advisors and cite this. This is entirely made up data that we have for just this example. So if we want to run a linear regression, we would go into Analyze, Regression, and then Linear. And this is the window that would pop up. We're going to point out now and also later, this is the exact same box that would pop up for a multiple regression. The only difference is how many variables go in this independence box. This is for our IVs is the independence, and dependent is our DVs. And like before, you just highlight and scooch over the variable into its relative box for you. If you need some specific statistics, let's say you need things like R squared, or you want to come out with means for everything, you can click into statistics, and from this window, it can also create things like plots just by toggling that menu all the way to the right. From here, you would click again, OK, and paste, like we said before. And the output will look like how it comes out on the left. Like I said earlier, we have the equation of a line written over on the right, where we have the predicted value of y equal to the y-intercept plus the regression coefficient, which is the slope, times x. That's the same equation of a line, just written in slightly different notations than you might have seen in high school or middle school. But I have this just to map it onto it if it's helpful for you. If that looks intimidating, please feel free to ignore it. It's not super relevant for if you don't like thinking of things in linear algebraic terms. So how do we read this output in SPSS? So you're going to see it says regression and then variables entered or removed. This tells you if SPSS had any issues with the independent variables that you put in and needed to remove them. So right now it says sleep was entered, so there's no issue, none of our variables were removed. But if it didn't use sleep and something was going wrong with that variable, it would be in the next box over under variables removed. So this is just a check to make sure everything that we want to be in the equation is in the equation. From there, we see the model summary box, and this is a brief overview of did we predict and how well did we predict our dependent variable. And if you forgot what our dependent variable was, under that variables entered and removed box, you'll see a line that starts with A and a line that starts with B. It tells you our dependent variable is right, which was our writing time variable. And it also tells us in plain English that all our variables were successfully added. So we were reminded that we want to predict our writing variable. And our regression coefficient is that R right there, which we see here is 6.55. And that is our predictors of sleep and also a regression constant, like you can see in the equation. R squared is the next box over under model summary. And here we see it's 0.29. What R squared is the percent of variance in Y that is explained by X. Putting that in different terms, about 43% based on 0.429. So about 43% of the variability in how much time I spend writing can be explained by how much I slept the night before. So we can explain 43% of the variability in writing time by the variability in sleep time. There's also a measure of R squared adjusted for various inflation factors, as well as standard errors of that estimate. From there, you'll see an ANOVA box. The reason why this happens is an ANOVA is actually just a more specific version of regression. ANOVAs are actually regression where the IV is a categorical variable. So SPSS is trying to be helpful and give you some of that information in different ways. I'm going to move us past those sums of squares, degrees of freedom, mean squares, and F values. When you're reporting things in APA format, you might need those degrees of freedom for your equations. But for right now, we're going to jump all the way over into that significance value that you can see is 0.008. That is our p-value for the entire model. So it's telling us, did we successfully predict the amount of time we spent writing from all the variables we entered in our model? And our general cutoff for that is less than 0.05. And since 0.008 is less than 0.05, we have successfully predicted a usable amount of variability in writing time based on what we have included in here. From there, we're going to look at the coefficients box, and this is going to break down all the variables one at a time that we entered into our model. So it has a constant, which, like we said before, is that IY in the equation. That is the the y-intercept if you're wanting to think in linear algebra terms, but if you're not, feel free to ignore that box, and we can move down into the sleep box. Here we can see both an unstandardized and a standardized regression coefficient. I'll explain those in just a second. But then if you scooch a little bit further into that sig and then move down into the sleep line, you'll see that 0.008. This is telling us that is the p-value for if sleep is a significant predictor of writing time. And since it's lower than our threshold of 0.05, we see that sleep is a significant predictor of sleep. But how much is it a significant predictor of sleep? That goes into our unstandardized and our standardized coefficients. So we can know for every 1 unit change in our sleep variable. So for every extra hour that I have slept, my writing time has increased by 0.582. So for every extra hour I've slept, I've written my thesis for about another hour, half hour than I would have if I had done so previously. And those unstandardized and standardized beta coefficients can be interpreted as both direction, and the standardized ones can be interpreted as magnitude in the same way you would interpret a correlation coefficient. The unstandardized ones are just on the scale of the variables themselves, which might be a little bit more detailed than most folks need for it. Most articles in most fields have their norms for if you would report unstandardized versus standardized. So that was a lot. We're going to break down the multiple regressions now too. It is almost identical to our single regression, our simple regression, except we're going to have multiple predictors. So let's go back to our example where we want to predict how many hours a day a graduate student writes their thesis. But let's say that we don't think sleep is the only thing that is contributing to that writing time. What if we also think that it's how many minutes that we exercise the day before? Maybe exercise really motivates me to get writing, or maybe exercise takes up extra time in my day and it takes away from writing. So that might also happen with sleep to predict how long I'm writing my thesis. Again, this is not real data, so this is not a real conclusion we can take into account here. So we are specifically interested, and this is good notation to look at later if you're running a multiple regression, is we want to know if sleep predicts hours of writing if we hold exercise constant and vice versa. So how does increasing 1 hour of sleep influence writing time given a certain value of exercise? And in the opposite way, if we hold sleep constant and increase exercise by 1 hour, what will happen to our writing time? And so those are the questions that we are going to ask. So like I mentioned before, what differentiates a simple versus a multiple linear regression is having 2 continuous independent predictors, but only 1 continuous dependent predictor. This is looking at how independent predictor 1 and independent predictor 2, and potentially more so if you need to add more, are collectively together associated with our y variable, our dependent variable. So it's worth noting here in our simple linear regression, we were looking at total effects in y, but now we're looking at partial effects in y. So sleep might be having a partial effect in y, and exercise might also having an independent partial effect in y, and they are together having a total effect in y. We'll explain that a little bit more when we can look at the data. That might make it a little bit more concrete. So one more way to phrase this, and some way that you might want to put in your individual studies and manuscripts, is what is the predicted change in y given a 1 unit change in x holding the other x variables constant? So exactly like before, we're going to click Analyze, Regression, and Linear, and it's going to take us exactly back using these buttons to that same spot that we saw before. But now we're going to add more variables into this independent box. We're going to add both sleep, and I guess we're operationalizing exercise as running, which to me personally sounds absolutely awful. But here we have our writing in our dependent variables, and we have sleep and running in our independent variables. From here, like always, we're going to press OK or press Paste. And this is what the output comes out. So, like I said, you can still have that equation of a line like you would in linear algebra. If this is intimidating to you, please feel free to ignore it, but it just has different slopes for x1 and different intercepts for x1 and also for x2, and that's the only change from what you saw before. So let's go back to this output. Like before, it has the variables entered. So you can see that both sleep and running were successfully entered and nothing was removed, which is great. And our dependent variable is writing, written below by that A asterisk here. And then now looking at our model summary, we see our overall model regression coefficient is going to be 0.675. And here we see our R squared. So this is the total amount of variability in writing time that is predicted by all of our predictor variables. So both sleep and time spent exercising. So this is the percent of variance in Y predicted by both X1 and X2. So we can predict about 46% of the variance in writing time from how much someone was exercising the day before and how much they were sleeping the night before, as when you combine them together. Going to our ANOVA table, like before, this significant box down here is going to tell us, do we have a significant model at all? So did we significantly predict a notable amount of variance in writing time? And since this 0.026 is below our 0.05 threshold, we have significantly predicted some amount of variability in writing, but we don't know which variables were carrying their own weight. And the way we find that out is going down to this coefficients box. Like before, the first line is our constant, which is our y-intercept. And then the next line is our sleep variable, and then the unstandardized regression coefficient for sleep. So this is saying that for every 1 unit change in sleep, the writing time increases by 0.509 hours, so about half an hour. And if we keep going all the way over here to the significance in that middle line, we see that it is 0.033, and that is the p-value for if sleep is a significant predictor for writing. And since that is below our 0.05 threshold, we see that sleep significantly predicts variability in writing time. But if we do the same thing for running, we see our running variable, we still have an unstandardized regression coefficient, but is running a significant predictor? If we scooch all the way over here to our significance box, we see that our p-value is 0.45, which is way above our threshold of 0.05. And that means that when accounting for sleep in our model, running and the amount of time someone spends running does not significantly predict how much time they're going to spend writing their thesis, again, when accounting for sleep. So that was a lot. We are not expecting or hoping that you have memorized it from what we're saying here. We're hoping that when you have to run a multiple linear regression, you might pull these up to help you interpret your own results, should it be helpful to you. And so from here, we're going to move on to some extra tips, but I think this is also a good time to pause to ask if anyone has any questions on any of our analyses so far.
Okay. I will keep an eye out on this chat box here just in case some question comes up. But in the meantime, I'll go ahead and start doing some of the extra tips. So let's start off with talking about really what the purpose of this syntax is. We've touched on it here and there throughout this webinar, but just to make it really explicit, syntax is a way to not only make your work replicable, but it makes your work more supported by open science practices. You can share this syntax file with collaborators so that they can replicate your work. You could use syntax to check your own work, for example. So let's say that I just wanted to give myself a little secondhand pass of this. I could check my syntax instead of rerunning all of the analyses. I could look at what I'm running and see if it was what I was going for. Another thing that you can double check with syntax is recode values. So let's say that I created a composite variable and I don't remember what numeric expression I used to calculate that. Or let's say I recoded 1s to be 3s and 2s to be 1s in a variable. And I don't remember that. I could go to my syntax and I'd be able to find that information that way. Again, you can directly post these syntax files. This can be a part of your way of supporting open science by directly giving these syntax files to others to use. And in turn, that is again supporting replicability. So there's a variety of other purposes that you're going to get from using syntax, and a lot of them are just like personal benefits. So one of those personal benefits is that once you've established syntax, you're going to have that to be able to use for your own on the rest of your projects. So for example, I have a study where I have a 5-study package where I was exploring what is the role of this manipulation on X? I'll just keep it simple for the example. I used a different manipulation in each of these projects. But since I already ran the code on one, all I had to do was edit the variables within that code to rerun it again on my next variable data set. So instead of taking, a few hours to write that syntax file the first time, for data sets 2 through 4 and 5, I was able just to take that syntax I had already written and edit it from there. So this saved me time. So that was a personal benefit that I received in addition to all of those like more pro-social things like replicability in open science. So we can also talk a bit about like what it actually means to edit your own syntax, because it's totally understandable if you've never worked with this syntax before, if you've never worked with code before, that editing it or writing your own code is going to seem a little difficult, but we're going to hopefully break it down so that we can make this an easy process for you. So overall, what I'm going to be showing you on the next slide is how I edit my own syntax to reuse it in other data sets. But the goal here is to take that code and edit it as little as possible to make it work for what you're wanting to do. And we'll get into some of the details of what that means, but you're just wanting to maintain the integrity of the code there. This syntax, this code, it can be finicky. So by taking syntax that you know has worked in the past and just editing the information that you need to, you cannot have to deal with as many errors. So let's see what that actually looks like. So let's say that I had this line of code to run descriptives in one of my old projects. Here you can see that I was running descriptives on a height variable. Specifically, I wanted SPSS to tell me the following statistics: mean, standard deviation, the minimum value, and the maximum value. So I would take this code and I would try to identify what are the actual variables in this code. What is code that's telling SPSS what to do versus what is an indicator of an actual variable that I have in this data set. So in this example, you could see that the word height here is the variable in this syntax code. So I would take note of where that is. And if I was wanting to run descriptives on a different variable, say test score, I would change only that one word of the code. Every single other word, every other space, every other punctuation within this line of syntax is the exact same as when I used it in my old project. So there's a few other things to keep in mind here that I've mentioned kind of quickly as I was giving some tips on how to edit syntax. So the number of spaces matter. When I put the word test score here, I did not add or remove the number of spaces in between the equal sign and the variable name or the variable name and the word statistics here. I also wanted to note that capitalization matters here. So you can see that some of these words are in all caps. Some of these words have capitalization within the word. These are all things that are going to matter. So you want to keep note of how you capitalize things in your variable name. And also that's just something that you want to keep consistent when you're using code that you've ran previously. And lastly, knowing that this capitalization matters, you don't actually have to type in letter for letter what this variable is when you're editing code. So in this example, you do not have to write out letter for letter test score when editing from height to test score. You can just write the first few letters, so say capital T, E, S, and it'll give you all the variables that those are the first few letters from. So then you could just click on test score, that's another point and click option, and it will auto-populate the whole word test score there for you.